Now let's see how we can make our these particles follow the line. And right now we are using these noised up velocity volumes to make our this noised up particle movement. So let's go back into the SOP, and in here let's build a volume for our this line. And right now we have this just simple box filled with some noised up velocities, and I'm going to just select all of these nodes and move them aside. And in here maybe I'm onto the helix node. Let's keep this onto the third input. Onto the helix, I'm going to convert this into NA velocity volumes, and we can do so by first building our own velocity vectors. And right now if I were to middle mouse button, and here as you can see we do not have a vector attribute in here, and we only have an AP. And what I can do, if I go into my helix node, and if you scroll down, we have some output attributes. Let's collapse this menu, let's scroll down, and in here we have the tangent z-axis. If I were to enable this, and it will create an attribute and mean the normals. And if I were to middle mouse button, and here as you can see we have the n, it is a vector, and this tangent z-axis will going to be store the vector that will follow the path of this line. And I can visualize this n. If I were go into this display normals, you know that we can display our normals by clicking on this button. This will display our point normals, and right now we have the normals because n is a normal attribute. So let's enable this, and in here if I zoom in, and here you will see we have these vectors. And if I were just change my camera angle, and in here you will see that we have these vectors, and they are following our line. So we have some vector information, we have the direction information, and now we just need to convert this direction into volume. And in here first I'm going to add a thickness to my line, because right now we have this infinitely thin line. And to add the thickness, I'm going to use a polywire node. So if you type polywire, let's add this and connect this in between. And what it will do, it will just make this line into a cylindrical shape. It will add the thickness in here. And I'm going to go into the polywire, and we have some parameter. Let's increase the wire radius, and that will increase this radius. And right now we are using this a square, this four-sided. I can change the divisions. If I come over here as you can see we have the divisions, and if you continue increasing this division, I can make these thickness and a smoother cylindrical shape. So maybe let's increase some of the divisions value to have this smooth looking shape. And we also have some UVs. If I zoom in, and here as you can see we have some UVs, and we have this weird visualization of our viewport. And here as you can see, and this weird visualization is actually coming from this normal. And as you know, we have the normals, we have these normals vector, and if the normals are present onto our line, this polywire will going to be inherit these normals to set the normals. And here as you can see we have these normals visualized, and because of the weird angle of these normals we have this shading problems. And if I were to recompute my normal, let's add a normal node, and that way we can recompute the normals. And let's view this again, and now if I let me hide this, and here as you can see this geometry has been converted, or this line has been converted into this thick geometry accurately, and we do not have any problems, and because we are fixing the normals. But We do not need to fix the normals because I like these normal. I'm using this to just add a thickness. And now that we have the thickness, I can convert these V attribute into volume. And to actually convert this, we have a node called volume rasterize attribute. So let's add a volume rasterize attributes node. Add this and connect this in between. And in here, I'm going to select the attribute that I want to convert, and the attribute is called the N. And now we are creating the N vector volume. And if I were to middle mouse button and it's still saying V, let's press and hold middle mouse again. And now we have this one VDB volume, it's N and it is a vector. And I know that that is the direction I want my particles to move. And now let's import these velocity volume into our particle simulation. Let's go into the topnet. Let's dive inside, and this time let's go into the pop advect by volume. Right now we are using the third context. We are using this box, but let's import this second context geometry. So let's go into the topnet node, pop advect, and in here let's change this to second context. And now if I hit play and these particles are not moving, let me see if I were to template my polywire, and here as you can see our particles are not moving because we are not in the proximity of this line. And let's adjust this emitter, and to actually make this work we must be inside of this proximity, otherwise it won't follow, because outside of this region we do not have velocity information. If velocity information is not there, our particles will not move. Let's play around with the center, and maybe let's play around with the orientation. Let's change this to XY plane, and also let's move them in here. Adjust this. I'm going to make its uniform scale so that we have this source inside. Maybe let's keep adjusting its position. And right now our source is a little bit outside, but that is fine, that is good. Now if I were to dive inside and hit play, and it is still not moving, and that is not moving because we forgot to actually rename the volume name, because right now we are using the V. But if we go back in here, as you can see our velocity volume has been renamed to N. So which means I need to go into the topnet and in here update the name. I can say that now that I want to import the N, because that is the volume that stored the velocities. So capital N. Let's add this, and now we should see, and here as you can see we have these particles moving, and they should follow the path of our line. And right now we are using the advection type. We are making this to update as a force, and we are using is as a wind force, because treat as wind option is enabled. I can disable this, and now we can update this as a force, and force is a bit more brutal force. If I were to hit play, and here you can see over time our particles are getting accelerated. I can go into the velocity scale, I can increase the velocity scale, and now our particle will follow them a bit faster. And in here, let me go back onto the pop advect. We have some other advection method. We can change this to update velocities, which means we are going to be updating our own these particle velocities with these velocity volumes. So maybe let's change this to update velocity, and let's hit play. And now here you can see by changing this to update velocity, our particles are adhering to this line up better. And after that, maybe let's add a pop drag, because pop drag always help. So let's add a pop drag node in here and add this after the pop advect, and let's hit play. And here you will see that or these particle will guarantee to follow the path that we have just built. And right now its speed is slow. Let's go into the pop advect and maybe let's increase the update scale. And in here now we have a faster movement and they are following the path. And in here I can add a noise on top because right now we have a very smooth movement. So what I can do, I can use the pop wind node in here and let me check, and here we have some noise. Let's hit play and here you will see that we have some noise introduced. And I'm going to let's increase the amplitude to add a bit more breakups. And here we have the noise and now this movement is looking good. And right now the visualization is a bit weird, so let's go into the pop color node. And in here we are using the range. Right now we are using the range in 0 to 1 range. And because we have a faster movement of particles, and if I go into the pop advect by volume, and here as you can see we are using the velocity scale of 5.9. So as you know that this velocity are not in 0 to 1 range, but we have a higher values. So let's go into the pop color and let's adjust the range accordingly. I'm going to just press and hold the middle mouse button and just keep increasing this range. And here you will see that the color is adjusting. And I'm going to maybe let's change this to a value of 5.9. And we have this visualization back. And now we have this accurate this good visualization. And we have some noise. And let's go into the pop advect, and here as you can see we have this velocity blend option. It means that we are blending the velocity from this top net. We have this pop wind, so we are using 0.5 as a blending amount. I can change this to 1, which means we are fully blending both of our velocity volumes. We are going to be utilizing the pop advect and pop wind fully. And if I were to hit play, and here as you can see both of these forces will have a equal effect, and it's following this path better. Let's go back, and in here I can introduce the noise onto these velocity volumes. And right now we are using the pop wind node to add a noise. What I can do, I can add a noise onto these vectors because right now we have this very smooth information. And I can actually visualize this by creating my own this volume trail node. And first we need the points, and for that I'm going to fill this polywire geometry with points because right now it is a hollow piece of polygonal geometry. And to make this fill, I'm going to add a points from volume node that will just fill our polygonal geometry with points. Let's add this and view this, and here as you can see we have these particles inside. Now let's add a volume trail node in here, volume trail node, and it needs the velocity volume, that is the velocity volume, and the points to trail. And we have these points. Let's view this. Sorry, let me connect this again and view this in here. And here you will see these are the velocity volume visualized in red. And in here let's introduce some noise, and I can do so by adding a volume noise node. So let's add volume noise vector, and let's connect this after we have converted this into volume. And right now it is using the vector volume name v, but in here as you know that we have the attribute and it is set to n. So what I can do maybe to fix this, let's go into the helix, and in here let's not export this as an maybe let's change this to v. So in here we should have an attribute name v, so which means that this polywire node will inherit a v attribute. And here as you can see we have the v, And we have our this proper visualization of normals because we are not creating the normals and Polywire will creating the normals itself. And we have this good visualization. Let's go into the volume rasterize, and in here let's not pick the n because n no longer exists, but we have the v. And now we have this velocity volume name v, and that is good. Now let's go into the volume trail node, and all of these nodes, as you know, that they are designed to work with v by default. And let me remove this p. Let's go into the volume trail node, and in here, now here as you can see, we have the noise introduced in here because we are adding the noise on top of our these velocity vectors. If I were to zero out the amplitude, and here as you can see, we do not have any noise. And if I were to start adding the amplitude, here as you can see, we are distorting our these velocities with the noise. And I can play around with the element size to create a more high frequency or low frequency noise. And if I were to load this value down, and here as you can see, I am adding lot more smaller breakups. We have these smaller swirls, and same thing, if I were to increase the element size, we have these bigger swirls. So let's change this to an MAB value of 0.7, and now I want to connect this into the second input because that is our new velocities. Let's go into the top net, and in here we need to update this pop advect by volume. And now let's change this back to V because we have created the V, and let's hit play. And here as you can see, we have the noised up movement, and I can confirm. Let's go into the pop wind and just shake this node off. So which means that we only have pop advect by volume node. And let's hit play, and here you will see we have the noised up velocities. And in here, as you can see, we have these particles. Some of the particles are sticking. We have this sticking effect, and that is because all of the particles that will try to leave the bounds. If I were to visualize my this Polywire, and here as you can see, we have these bounds. Let me enable my particles, and let me template my this Polywire. And if I were to hit play, and here as you can see, all of these that will try to leave the bounds will going to be stick because it's outside of these bounds we do not have velocities information. And to actually fix this, what I can do, I can just remove the particles that will try to leave these bounds, this bounding box geometry. And I can do so by maybe let's remove this volume trail node because that is for the visualization, or maybe let's just keep them in here and place it inside onto the side. And let's go into the DOP net. In here I can add an APOP collision node. So let's add an APOP collision, and in here I'm going to say pop collision detect. So let's add this and connect this in between somewhere. And in here we can define the swap path that will look for the collision, or I can just connect this into my this lost input. And here you can see our this node graph is getting very messy. And by the way, you can change your wiring style if you press Shift S key, and that will change your wiring style to a smoother looking wires. And in here I can just pick this Polywire node. So let's go into the top net, and onto the pop collision I can change this to onto this context, or I can just go and pick my own this Polywire. Let me find, we are in the geometry and we should see the Polywire, and here we have it, and hit accept. And here we are visualizing this as we have the guides. We are visualizing this, which means that we are importing it. And now onto the behavior tab, right now we are coloring our particles, which means all of the particles that will try to leave will get a color value of red, and right now this red color is going to be overwritten by this pop color node. That is why we cannot see the red color. So I'm going to just shake this pop color node, and now if I were to hit play, and here you will see that all of the particles that will leave the bounds will get a red color. So what I can do, I can go into the pop advect by volume, into the pop collision. In here right now response is set to none. So I can say make all of these particles die. So which means that all of the particles that will try to leave the bounds will going to be get deleted. And if I were to hit play, and here you will see particles will live only inside of the bounds, and right now it is actually not following correctly. So we need to go into the pop advect and play around with the parameter. And in here right now we have the advection method. We are using the single step. Maybe let's change this to trace, and trace will create a good looking result. So whenever you are working with volume, make sure to change this to trace, and it will trace our these velocities better. And in here I can play around with the update velocity scale. So maybe let's lower this value down, and let's go back. And in here all of these actually coming from our this volume noise. So maybe let's lower down the amplitude to not create that much of the noised up. And now here you will see that our these particles are following the line, and if they try to leave they will get deleted. So in here you can use the pop wind node. I'm going to add a pop wind to add the noise. Let's hit rewind and hit play, and here you will see that we have some noise introduced in here. Maybe let's go into the pop collision detect, and let's uncheck this guide to hide the guide. And let's go on to the pop color. Let's add pop color node in here to so that we have our visualization back. And in here I'm going to adjust the range. Let's play around with its range value, lower this down, and we have our this good visualization. And let's go back, and in here let's view this with our this particle fluid surface. And here as you can see we are creating our this splash. We are directing our this splash like effect, and you actually do not need to add this. We have these particles, they're following the line. So that's how you can create your own custom forces with the volume.